Hello guys, welcome back to another programming video. Today we are going to be taking a look at a very simple rock, paper, scissors code. Um, the A rock, paper, scissors game is extremely easy to build, even if you think that this is very daunting. And then I will go through each line of code step by step, right? So first of all, package Java test. This is just some Java technicalities here. Because my file name is called Java test, it just needs to import that package. So if you're on an online IDE, you don't need to have this line of package, but if you are on Eclipse, I believe it will load this line for you, so you don't have to worry about it. Next, we import the input output module. It is called scanner from Java util. This will just basically read any input from the user. So really quickly, I'm just going to compile this, and it says, okay, main class. Okay, I'm running a different, because I was doing another project. Yeah, see, I was doing another project right before, so yeah, and then I'm gonna do rock paper scissors. There we go. There we go. As you can see, it says please enter move rock. So R equals rock, P equals P, P equals paper, and then S equals scissors. So let's go rock, and the computer plays rock. It's a tie. We can do again. I'll go rock again, and then we won right there, and then we can more time computer play. So this just basically goes through like the logic of this is that you enter move, and then the computer will choose a random move, and then it will compare, like for example, if you enter P but the computer enter R, then you win. If you enter P and the computer enters P, then it's a tie, and so on and so forth, right? So next we have our main class definition. So I've named this rock paper scissors because that's basically the name of the project that we're doing. Next we have public static void main. This is our first main function. This is like easy boilerplate code for any Java project, so I don't think I have to explain that in depth too much. Next, we have a person play for the person, so string person play. So this will just basically be the input that the human puts in, and then string computer play. It's right now quotation. There's no string in here. It's just empty quotation marks because the move has yet to be decided. And then int computer int, this will be used to judge the random output that the computer gives. And then string response. I was testing with it, but I don't think we need response right now. Yeah, because I was playing around with some things, and then yeah. Okay, so yeah, we don't need response right now. Then we have scanner, scan, use scanner. So this is like, this is defining the scanner class, or no, object, sorry. So we basically, scanner, so that's a type, and then we're calling the variable a scan, and then new scanner object and system.in, that will be input, and random, it's just basically for the random choice that the computer will do. This is for the directions, please enter move, blah blah blah. And then now we have computer int equals random not next int. So this basically chooses an int from from 1 to 3. So next int, so integer from 3 into the parentheses plus 1, so from 1 to 3. Here we have it conditional. So for example, if the computer int plays R, or if the computer chooses 1, then then computer play equals R. If computer chooses 2, then computer plays B. So this is just defining on this is defining like what the play is when the computer chooses the actual number itself. So This is a actual, like, I would say, sideways road. It is a longer road. First, you have to find a random integer. Then you have to translate the integer to a string. But that's probably the easiest way to understand. So that's why I'm doing it right now. Then you have your prompt for the user, and then person play equals scan. So scan right here dot next, that will create a string. I believe we can also do next string. If I'm not mistaken, we can't do next string. That's invalid syntax. Okay. And here what it says is that it will basically ignore all lowercase and turn the lowercase into an uppercase. This is basically a sort of double net layer, so that if someone accidentally enters a lowercase, there won't be a error message, because we will always make it an uppercase. Here we have a load of just if statements. If person play is that, then computer. So if, for example, person play is R, if computer play is R, then we have tie. If it's P, and then the computer wins, so on and so forth. And as you can see, this is a right here we have something that's different from Python. In Python, you can just do an equals equals sign, but in Java you can't do that, because equals equals is only for floats and integer types, for what we call I believe primitive types, and because a string is not a primitive type, you can't use equals equals. You have to use equals, so dot equals, and then either use ignore case or case. Again, ignore case is like a back layer to like protect if a user accidentally enters a lowercase. Yeah. So, I think this is it. We have a nice little rock paper scissors game right here. Yeah. So I'll just scroll through it one last time. You can pause any point of the video if you want to copy the code. And then we will go on to a even more basic calculator app, because the calculator does, even though it's not like such a difficult or algorithmic program, it does still have some meaning for the beginner programmers. So yeah. So again, you can pause the video to copy the code, and now we'll pop over to our calculator. So this basically has you enter the operation, and then has you enter the two numbers that you want to operate on, right? So I should have created a line here. There we go. So again, scanner, input, output, Java test again, and then name calculator. So class, and then main function, create scanner object, system.in, and then prompt what operation. So the operation can be addition, subtraction, division, multiplication, modulus, floor, and power or exponentation. And then you have the two numbers and its next float, so that there's float and integer coverage for a more varietized calculator. And then first and second number, and then just if operation dot equals. So I'm using equals right now because this is not an alphanumeric character, so we can't do ignore case. We have to do just dot equals. And as you can see, if we run this, let's see here. Do we have it, or do you have to? If we run that, okay, yeah. What operation? So let's do addition, and let's do 2, 3. And as you can see, we get 5. If we do multiplication, 2, 3, as you can see, we get 6. If we do modulus, modulus will basically return the remainder after division. So let's say 3 divided by 2, the quotient is 1 and the remainder is 1, right? And as you can see, we have 1.0. If you don't believe me, you can Google it, 3 modulus 2. And then if we do floor will basically divide and round the number down always. So let's see, if we do 3, 2, the floor of it is again 1. If we do floor 4, 2, the floor is just 2.0 because 4 divided by 2 is already 2. If we do floor see, 5, 2, it's 2 because 5 divided by 2 equals, what's 5 divided by 2? Yeah. So 5 divided by 2 is 2.5, and as you can see, it rounds it down to 2. And of course, we have exponentation. I need to first find the exponent key real quick because I don't know where that is. There you go. And then 3 to the power of 2 equals 9. Perfect. Okay. So again, this is pretty easy. All you need to do is to create input for operation, input for first number, input for second number, and then input for and then do an if statement, recognizing all the different types of operations that you can do, and then yeah, so that's it. I just want to apologize. I have not been uploading. Like my last video was on like June the 2nd. And this was because I did go camping with my family. So I couldn't make videos, of course. So yeah, I'm back, and I'll make some more videos probably tomorrow or the next day. But anyway, stay safe, guys. Have a good summer, and I hope you learned something from today's very short lesson. So